As you mentioned, I'm Xiyu. I'm a software engineer at Intrinsic. I mainly work on software development for robotics applications. I understand that this is the school of computing, but what I'm about to share today is very robotics heavy. So maybe I can just get a check. How many of you are familiar with or work on robotics projects? Yeah, there's a few, right? There's a few right here. Has anyone heard of ROS before? ROS, a robots operating system. Anyone familiar with Gazebo? It's a simulator. Oh, you guys know. Hey, that's good, that's good. Today I'm about to share Open-RMF. Okay, has anyone heard of Open-RMF before? No, of course. Okay, so I'll just dive right into it. So I'm not sure if you heard of Open Robotics. It's an organization that initiated like a few major open source projects. So ROS and Gazebo are part of the projects. They are pretty much the first things that you will get to know and start to learn and use when you get into robotics. And they are widely used in the global community as well. There's a lot of people using, creating their own packages, and even contributing to the core ROS tools and Gazebo plugins. Yeah, so for myself, I'm part of the Open Robotics team here in Singapore, and our main project is Open-RMF. It was started here a few years ago to tackle interoperability challenges. So what do I mean by interoperability, right? So today there's a lot of different types of robots in the ecosystem, different robots that uses different APIs that achieve different types of things. So you have like, in a duo, you have your security robots that walk around and tell you to go away. You have delivery robots that helps you deliver an item from point A to point B, and you have your cleaning robots that moves around big spaces and sort of help you mop your floor and stuff, right? So we have a lot of cool robots. And there's a lot of real-life requirements for all these robots to coexist together in a single environment. However, mobile robots actually struggle to behave cooperatively. So can you imagine two identical robots? They are trying to get to, they are sort of facing each other and trying to get past one another. They are unable to move because their path is blocked by the other robot. So they get stuck there indefinitely waiting for their path to clear. So this is a huge problem in uncontrolled and unstructured environments. There are people walking past, there are like obstacles like chairs and stuff that may move at any point of time. And this is even worse when we have robots of different models and APIs. So for humans, we can speak in different languages, right? For robots, they may use different protocols to communicate. For them to tell you where they are, their current position, or for you to command them to move from one point to another. So it's really difficult to get different types of robots to coexist in dynamic spaces. So the objective of Open-RMF is really to enable different robot fleets to share the spaces effectively. And RMF, when you want to launch it in simulation, it can look something like this. So on your left, it has a simulation of a hotel world that we set up. And on your right is a visualization tool called RViz, where we show you the robot's lanes and waypoints. You see the blue and orange lines. Those are the lanes that the robots are allowed to move along in RMF. And the green lines are their plane trajectories. So you can see we have different types of robots in this simulation. They can sort of use the space effectively, and they can carry out their respective tasks, all at the same time without bumping into each other. So RMF aims to tackle three main challenges, right? Firstly, like I mentioned, it is helping robots to share dynamic spaces. So like the example just now, when two robots are coming head-on to one another, how are they going to manage that? How are they going to give way to one another? If the robots are going to conflict at an intersection, how are they going to manage that as well? Next, you can imagine if we want a robot to operate in a huge building, it definitely has to pass through doors. It definitely has to access different levels by taking the lift, but we do not want a human being to be there to open the doors for them and to press the lift for them, because that kind of defeats the purpose, right? So RMF also allows you to integrate with building infrastructure such as doors and lift. So RMF would be the one controlling the doors to open whenever a robot needs to pass through, and sort of to allow the command the lift so that the robot can take them to level 1 to 2, for example. RMF also allows you to synchronize with other types of devices. So for example, you want a robot to deliver something from here to there, but the robot itself just has wheels. It can move around, but it cannot pick the thing up. So you might have an external device that is capable of doing this. You can integrate that with RMF, and it will allow your device and the robots to work together to complete this type of task. Yeah, and RMF has 4 important components in its design. So firstly, we have a shared traffic schedule, which really means that all the robots, whenever they are moving around, they have to openly communicate their intended trajectories through space and time. So we always know where every single robot is planning to travel to. This will allow us to point out at which point of time would there be a possible conflict where they cross paths and would come head on to one another. And then RMF would be able to negotiate and resolve these conflicts. So we have peer-to-peer negotiation process to make sure that the robots can reroute or give way to one another when these conflicts happen. RMF has a task auctioning system. So when you submit a task, you don't submit to each individual robots, right? We want to have a unified platform, which is RMF. And when you submit a task to RMF, it will first find which robot is capable of performing this task. We don't want a cleaning robot to perform a delivery task, right? And secondly, RMF will also find a robot that can complete it at the lowest cost. And in this case, cost means time. So if I have a task that's only mainly happening at level 1 and I have a robot here, I wouldn't want RMF to allocate the robot up at level 3 because there's additional time taken to move up and down. And lastly, RMF also provides a stable while evolving SDK. So we understand that we have to keep improving our code base. We have to keep adding new features and APIs in order for us to keep improving the piece of software. But at the same time, if someone integrated RMF a few years back, we want them to still be able to use our software. Yeah, so you can see RMF, whatever it offers you as 3 big groups. We have the fundamental components, which are non-negotiable items that you have to have when you launch RMF. They are the core components. For example, the negotiation system and the unified traffic schedule and task auctioning system. Without those, RMF cannot effectively allocate tasks to your robot and cannot effectively deconflict any traffic incidents. Yeah. We also have reusable software libraries. They are more of plug and play. So if you need it, you can launch them and use it along with RMF. So one example are web tools. We do have a web UI called RMF Web. So you can, for those of you who don't want to deal with the terminal and the command line, you can launch the web UI and sort of interact with your robots and your tasks and your building infrastructure from there. Lastly, we have platform adapters. So like I said, you want to integrate RMF with your robots, right? You have your hardware robot. They use a specific type of API. But RMF, we use ROS2 messages to operate. So how do these 2 components work together? We would have to have a middle layer, sort of a middleman called adapters to integrate all your hardware with the RMF framework. So this brings me to fleet adapters. What are they? They are responsible for handling communications between the core RMF components as well as your respective robot fleets. So can you imagine I have 3 different types of robots here, okay? And I would, with the different types of robots, I would need different fleet adapters to sort of act as my middleman. So for example, the first type of robot, it uses HTTP post and get for you to communicate with the robot, right? I will need my REST endpoints to get the robot's current robot state, and we will need the post endpoint to command the robot to move from one place to another. My second type of robot, however, uses MQTT. So then fleet adapter B would have to be able to use those set of APIs. And my third type of robot uses ROS2 messages. So my fleet adapter C would have to be embedded with the ROS2 topics. And the fleet adapters themselves are also able to communicate with our core RMF components with our ROS2 messages in the form of RMF internal messages. It's our own predefined sets of messages that we use within RMF. So fleet adapters are what you users would have to implement. You have to fill in the logic for those robot-specific API. For example, I mentioned REST API. You can just put in all your endpoints in the fleet adapter, and you should be good to go to launch your robot with RMF. And we do have 3 types of fleet adapters that have different extents of control for the robots. So firstly, we have this thing called read-only. Read-only really means that you can only, through RMF, you can only read where the robot's current position is. You can retrieve its robot state, you can retrieve its battery status, but you're not able to control the robot to move at all. There's a traffic light fleet adapter, so you have a little bit more control. You can get your robot to pause, stop at where it's at, and continue to move. So this is helpful if in the case where there's a robot passing by, and you can get your traffic light fleet robot to stop in its place, wait for the other robot to pass, and continue with its travel. And lastly, we have the full control fleet adapter, which is what it says. You have full control over the robot. You allow RMF to command your robot to move from one point to another. You allow RMF to send tasks to your robot. You allow RMF to reroute the task at any point of time it is going to optimize the traffic flow. So what does rerouting look like? So we have this, you see the same orange lines and points. So those are the lanes and the waypoints that your robots are allowed to move from. And like I think I mentioned earlier that the green lines are the planned trajectories. You notice the trajectories, they keep changing, right? It's because these two robots, they keep moving in such a way where their paths might cross. So at any point of time, RMF might have to reroute the robots so that to ensure that they do not conflict with one another or bump into one another. In cases where rerouting is not possible, like here, 4 robots are meant to cross a huge intersection with only 2 lanes. RMF can also get your robots to wait in place. So you see that the robot was waiting there until the other robot sort of traveled by, and when the coast is clear, then it can continue with its travels. And lastly, RMF can also help you manage building infrastructure resource sharing. So we have 2 robots here. They are at opposite sides of the room and there's a door between them. And they are trying to use the door at the same time. RMF will manage them and allow them to only use the door one by one and take turns, and also make sure that they don't bump into each other. And yeah, so now let's talk about the types of tasks that RMF supports. We pretty much support anything you want to happen, but we do have 3 things that we provide out of the box. So like patrol, which is moving from one place to another. We have delivery, which is to bring things from one place to another with a pick up and drop off action. And we have a cleaning task as well, which is to sort of turn on your cleaning tool and move around in a certain space. We are also able to write our own custom actions for your robot within RMF. So if you have a very specific action, for example, you want the robot to turn around 5 times, right? You are unable to achieve that with any of the provided tools that we have. But if you have the logic for it, you can plug it into the fleet adapter. You give this action a name called turn around 5 times. And then when you call for the task to do this, RMF will be able to allocate this specific task to your robot and trigger the logic that you have already filled in. And lastly, we also have something called a compose task. This really means that whatever you have up there, we take them as building blocks, which we call phases, and we put them in a sequence, and RMF will trigger them one by one. So for example, patrol, the name of the phase for patrol is go to place. So go to place means you go to that place, right? And for custom action, the phase is called perform action. It could be any action that you've written. And a compose task will look something like this. You can piece your go to place phase here, and then you add an action, add another go to place, and add another perform action. And RMF will take this as one single task and sort of trigger them one by one whenever you submit these particular tasks. Delivery tasks and clean tasks, which we provide out of the box, are actually also compose tasks. It's just that we recognize that it is more common for people to want to use this particular task, and we just package it nicely for you to use. And then moving on, how does one allow your robot to complete a task? So firstly, you have to create your task, obviously. You can use one that we've already provided, or you can create your own task with the compose building blocks. Then next, you would submit your task directly to RMF, and RMF would find the robot that is capable of doing it, and the robot that can complete it in the lowest amount of time. But if you would like, you can also directly assign a task to a specific robot in a specific fleet. And lastly, while your robot is performing the task, RMF will continuously monitor the state of the robot and any building infrastructure that your robot might need to use. For example, if your robot is at the door, RMF will know to command the door to open, and then your robot can move past it. And when your robot is done, then RMF will command the door to close. Yeah, and so in order for us to integrate with RMF, we must first have something called a navigation graph. Navigation graph is the collection of the lanes and waypoints that you saw earlier, so that you can define where your robot is allowed to move. It will also help greatly in in RMF to deconflict any possible traffic negotiations. Help you deconflict any deadlocks. Yeah. So you can define all these navigation graph using a tool called the RMS site editor. It's really a tool for you to set up everything in your world. So you can set up different levels that your robot is allowed to move on. You can create floors and walls and sort of bundle them up and put them into a simulator like the Xiyu. So you can simulate RMF. And you can also add doors and lifts. So these are important because then RMF would know to command your doors and lifts to cooperate with your robots as they are using all those facilities. Yeah. And actually, that is the end. So before we end, I just wanted to share that RMF is open source and you can definitely participate. Firstly, our GitHub there are a few repos. We have a lot of things on our GitHub. We have a lot of demos that we've set up. Feel free if you're interested to run through them. They're very fun and they're all in simulation, so you can definitely do that off your laptop. And for those of you who already have your robots and you're interested to integrate with RMF, feel free to try it out. We have a lot of templates and tutorials. And also, what do I want to say? Oh, we do have a set of a list of the adapters that we've already implemented with different types of robots. Like we can do with Nav2, you can do it with Mir robots. So if you have a turbo or something, you can sort of just take whatever exists and try running it on your own robots. Yeah, and if you are really invested in RMF, you can open tickets to inform us of any bugs, or if you have ideas for new features, can open tickets for those as well. But most importantly, if you want to participate as a community, please open pull requests to fix those bugs and write those new features. And we also would appreciate any help to update our documentation because we are rapidly developing, and any participation from you guys would be greatly appreciated. And the next way to get involved is to participate in our ROS meetup. So every few months we will have this meetup with people in Singapore who use ROS or work on ROS or want to learn about ROS. ROS is, I think I mentioned at the start of the talk, where it's a library of tools that helps with robotic software development. Yeah, so it's not just RMF specific, it's for really any robotics enthusiast. You can go there and listen to the speakers talk about their projects, or you could become a speaker yourself. You can see if you've done some amazing work, your friend did an amazing work but they're too shy, something is on the internet, as long as it's ROS related. Feel free to let any of the organizers know, and yeah, we would really love to hear from you. I didn't forget, I left this QR code, so the one on the left is the link to our Open-RMF website, which will link you to our GitHub code base, as well as our documentation, etc., etc. And on the one on the right is the Telegram invite link for the ROS meetup. Yeah, okay, I am done. Okay. Yeah.
I apologize for that, but I'm a little bit newbie in this field. But what about the communication between robots? You say with some peer-to-peer communication between them to share the fleet or the path they have to do. So which kind of communication they use for between robots to
So I believe you're talking about this peer-to-peer negotiation?
Yeah, exactly.
Yeah, so every robot, they sort of communicate in different ways, right? Like I illustrated here, right? So they would, these are the APIs for them to update you with their current state. But RMF, if it's a full control fleet adapter, RMF is the one that decides where they should go, their trajectories, their planned itinerary. So RMF would publish that on via ROS2 messages, and the robots themselves, because we have an idea of where each robot is meant to go via this, there is no master planner to decide every robot's trajectory. Only when we find a case where the robots might come into conflict, those two agents would try to negotiate with each other and see what is the lowest cost solution for one to give way to the other.
The lowest cost decision will be happen on the Open-RMF backend, not between them.
Correct.
Okay.
Yeah, but the peer-to-peer negotiation refers to the lack of a master planner planning all their routes. But they will determine their own routes, and only when a conflict happens, they will settle the negotiation between themselves.
Okay.
Yeah.
So which means they have to be connected each time for Wi-Fi connection, whatever.
Whatever mode that they use.
Yes. Okay. And another one, sorry. And then you mentioned also there is a way to open door, lift, and so on.
Mm-hmm.
So how it works? So the robot itself gets some sensor close to the lift, and then it sends a ROS message to Open-RMF to say, hey, I'm in front of the lift. Can you open the lift, the door, and stuff like that?
Yeah, so RMF will continuously monitor the robot as it's performing a task.
Yeah.
So the task can be made up of different events, right? It will move here, and then the next event is I will stop at a waypoint. The event that follows should be to open the door. And when that happens, RMF that has access to the planned itinerary and know at which progress it is, it will command the door to open.
Okay.
Yeah.
So at the end, Open-RMF is like the central point of everything. So if Open-RMF get done, everything get done. There is no more autonomous things to do, correct?
Exactly. Yeah. It's the framework that governs all this happening. Thank you.
I appreciate it.
No problem. Yep.
So the P2P logic is essentially code.
Yes, it's part of the code base.
So it's not like an IoT. It's not like an IoT communication.
No, they don't. The robots don't directly communicate to one another. Yeah, they just. Sorry.
Because of conflicts.
Because there is no good way for all the robots to be able to communicate with one another based on their APIs alone.
So they do it.
Yeah, they tell the feed adapter, and the feed adapter manages each feed of robot only. But the feed adapter will be able to relay all this information back up to the core RMF components.
Since it's a middleware, is it cloud hosted?
It is not. So you can run them locally, and you can also deploy them on the cloud. Yeah. So we actually recently deployed all these in local hospitals, and hospitals have their own network infrastructure. So we have to host them on their infrastructure. We have to deploy on their infrastructure. It really depends on what you need, and you can sort of cater to that accordingly, like via Docker and everything.
Since the RMF has access to a lot of important things like doors and the robots and everything, and so like, how do you ensure that these like devices are being controlled by RMF and not by some like malicious?
That's a great question. You cannot confirm that. Like if I have access directly to the robot, I'm still able to control it and stuff. So it really when you are deploying it, you have to ensure that you are setting up a secure system for your own deployment. Yeah.
Which we just jump on the same question. So it means that the robot itself has to be secure because you can control the robot and do something wrong.
Mm-hmm.
But Open-RMF should be also really secure.
Yes.
Because based on that, you can upload any new action plan, whatever, open door, and do because Open-RMF has the full API access to any kind of system.
Yeah. So you have to be in charge of deploying RMF with a secure system, and you have to be in charge of ensuring that the credentials to your robots are not leaked elsewhere. Yeah.
I'm curious about like the challenges of like integrating with like lifts and doors and things like that. Do like lift and door companies like expose like a nice API for you to like communicate with them?
Yeah, great question. So in my experience, you definitely have to work very closely with lift vendors. For us, we have our own sort of an integration package where we convert those I/O pins directly to as, for example, MQTT messages. We can translate between those two and have those MQTT messages be a lift adapter. I mentioned feed adapter, right? So for lifts, we also need a layer of adapter, and we can sort of convert those MQTT messages into ROS2 messages that RMF recognize. So depending on how you want to deploy it really, because there's so many different use cases for it. So depending on how you want to deploy it, you have to do your own conversion between the IO pins and RMF messages.
Share on the topic of lifts and doors, right? You know, in a building, there's also like humans using the lifts and doors.
Yeah.
And how does RMF like take that into account? Because you can't just like call the lift down and someone's waiting for you.
Yeah. So the way we've deployed in the past, if there is someone already using the lift, like I've already pressed the button in the lift, that will take precedence. If at any point RMF calls for the lift, RMF will be in control of the lift right when the person reaches the destination floor. Yeah. But if you're working closely with the lift vendors, you can sort those logic out because they are able to update the software according to your needs. Yeah. But that's a great question, and it always happens. Like the people halfway they are using, then they have to get out really quickly because the robot has already called for the lift. Yeah. Yeah.
Just now you mentioned that for Open-RMF to work, we first have to build a world using the world building tool.
Yeah.
So what if the mission or the objective of these robots, this fleet, is to explore the world where you build up the map as you go on the mission? Does that work for Open-RMF?
Good question as well. No, that does not work for Open-RMF. Open-RMF assumes that you already know what are the places in the world that is allowed to go, and assuming that you have already mapped out all these places on your robot itself. Yeah, it's not really used for exploration. It's used for completing tasks in a certain environment with other robots. Yeah.
And when you say import, which means that you can import flow from another device that already do the exploration, or
Yes. So if you, definitely. If your robot has already has mapped out the place, you can get that image and import it into the building map and create your own navigation graph according to that sort of blueprint.
Okay, my question was more about, let's say an example. I have this cleaning robot,
Mm-hmm.
Xiaomi or whatever the brand, and I suspect there is proprietary protocol, whatever, so they don't allow me to export the floor or the map that my cleaning robot did in my home to Open-RMF. There is no like a standard between product to say, hey, when a robot do like a discovery, it can produce this kind of file, and this file can be used everywhere for the robot world to be imported and do that. There is a standard like that, or?
No, unfortunately, when we say import floor plan, we really mean an image. So like 2D drawings of your building floor plan, you can import them into RMF and use them as a base. Is it the floor that has the L3 markings? Yeah, we don't really support any other formats as of now.
And is there, like say, people from that's working in the robot world try to make this kind of standards, try to standardize because you mentioned MQTT, REST API, whatever. So there is like a standardization about communication from robots, standardization about the floor map or stuff like that, or is it today it's so early and each people do what they want?
Exactly. Everyone is doing their own stuff. There's no standardization of what each robot could do because different protocols work best for different use cases as well. So it's understandable.
Okay.
I'm then curious about so what is like the Open-RMF team like working on to like implement next?
We are actually in the middle of writing a next generation of RMF, which because this started a few years back and it's been working well enough for us, but there are also a lot of drawbacks in this piece of software. So we are looking to rewrite it. Our project lead is his name is Gray. He's looking to rewrite it in Rust as well for memory safety, for all the benefits that you get from Rust. Yeah, so the next step is a rewrite and to use a library called Baby Impulse, which was written by him as well, where we will make RMF a lot more modular. So when you want to integrate with RMF, you can really pick and choose which part of the things that you will actually use and throw it into the system rather than being forced to use the system as a whole. Yeah. Think no more. Well done.
I think that first.
So, then,
Yeah.